Japan has introduced the first ever 6G device in the world, capable of transferring data at speeds 20 times faster than the existing 5G networks. This advanced technology is set to transform wireless connections dramatically and usher in a new phase of ultra fast digital speeds. With this innovative device, Japan is now leading the global competition to develop and implement future mobile networks. As our world grows more dependent on rapid and efficient connectivity, 6G technology prepares us for a future where instant, continuous communication and data sharing shall be the standard. 6G wireless networks are poised to revolutionize our world by integrating the physical, human, and digital realms. This session will introduce the key driver technologies and potential applications of 6G. It will also explore the evolving landscape of 6G research and development, such as holographic beamforming, integrated sensing and communication, and AI/ML driven network management. Furthermore, the session will discuss the potential impacts of 6G, including advancements in areas such as the Internet of Things, autonomous systems, and the metaverse. Participants will gain a foundational understanding of the exciting possibilities and challenges that lie ahead in the 6G era, including its all round technological perspective. I would first take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I would first welcome amongst us Professor Emin Huda Sir, Director, Bharati Vidyapeeth's Institute of Computer Applications and Management, BVI CAM, and Chairperson, IEEE Delhi Section, to address the participants with his inspiring words.
Am I audible, Dr. Ritika?
Yes, sir.
Great. So, good evening, one and all. And at the outset, let me welcome my today's valued speaker, Mr. Saro Velrajan, who is Head Digital Consulting, Gimcos India. I also take the opportunity to welcome my all other friends, including Mr. Ajay, the Chair of Industrial Relations Committee, the very honored uh, professional societies representatives amongst the attendees. So, welcome you all. Above all, the participants from various parts of the country and abroad who are part of this 164th webinar series, which is being organized since last almost 4.5 years, which was started in May 2020 in the backdrop of COVID-19, when entire world was just blank that what to do. And then we thought that let's start a knowledge dissemination session so that the people should remain busy in some constructive and some productive activities. And that was the humble background with which we started. And by now we have completed 164 such episodes. And all these recordings, video recordings are available on our YouTube channel. And for all this, the strength to me is the audience from different parts of the country, as well as the valued speakers. Any one of them, as and when we have approached, they never said no, and they have been on this platform to share their expertise and being with all of us. So thank you so much, my dear friends. This webinar series is in collaboration with IEEE Delhi section, IST Delhi section, then IET Delhi Center, CSI, and of course Bharati Vidyapeeth, to which my team, led by Dr. Ritika, is heading it. So thank you so much, my dear friends. The today's topic for which we have invited our valued speaker today, Mr. Saro, to discuss is exploring 6G network. Yes, Japan has started the 6G network. When we travel in the length and the breadth of the country, we keep on encountering from 1G to 5G. But nevertheless, the technology which is on the card, the technology which is coming must be welcomed. And that's why I keep on saying that there is nothing constant in this world except change. And either we change upfront or otherwise the competitive environment, technologically changing environment will change us. So all of us are ready to accept the changes, and we are adaptable, and we are rather eager to see what 6G will give to all of us. And that's why I always say, if you ask to people, they will say you that even 4G is not available to its fullest of the potential. What about 6G? But as a student of computer science, I always say that this kind of diversity will remain. And for a country, for a huge and diverse country like India, it is not possible that at all the places the same type of the technology can be implemented and can be made available to the people. There are constraints and there will be some or other differences from region to region. But despite that, we should be ready, we should be adaptable, and we should be ready to accept the changes and take the maximum advantage, the fullest advantage of the technology. That's why I always say that इंसान घर बदलता है, लिबास बदलता है, रिश्ते बदलता है, दोस्त बदलता है, फिर भी परेशान क्यों रहता है? क्योंकि हम अपने आप को नहीं बदलते. And that's how the Ghalib said that उम्र भर गालिब यही भूल करता रहा, धूल चेहरे पे थी और मैं आईना साफ करता रहा. तो हम टेक्नोलॉजी के निगेटिव साइड्स पे बहुत ज्यादा डिस्कशन करके डिसअपॉइंट होना नहीं चाहते. हम ये चाहते हैं कि जो टेक्नोलॉजी के पॉजिटिव एस्पेक्ट्स हैं वो हमें किस हद तक कनेक्ट करेगा और किस हद तक हम उसका एडवांटेज उठा पाएंगे, दैट वी मस्ट डिलिबरेट, फॉर विच द टुडेज सेशन हैज बीन organized. And dear friends, we are sure the kind of the technologies which are coming together to make 6G a reality that will completely transform the way we communicate, the way we interact, and the way also the way we have transaction, we transact rather, right? So in complete way, the changes are on the card, and we have invited Mr. Saro to help us to understand, to make us to understand that to which extent the technology is going to facilitate or technology is going to transform our day-to-day activity. Thank you so much. I was traveling somewhere, so I was stopped and thought that let me first interact with my guests, with my participants, with my friends, attend it, and then move forward. Thank you so much. Over to you, Dr. Ritika. Dear friends, around for next 2 months, rather 3 months, means remaining part of the February, then March, and then April. All Saturday webinar sessions have been notified. They are available on the website. You may go through the website, register, so that in time you receive the link and you receive the invitation. Wish you all the best. God bless you all. Keep learning despite disruptions and keep circulating this information amongst your friends. The audience and the participants who keep on attending it are the biggest source of strength to me. Thank you so much. Wish you all the best. God bless you all. Over to you, Dr. Ritika.
Thank you, sir. I would now welcome amongst us our speaker for the day, Mr. Saru Vellarajan, sir, with an e-bouquet. Welcome to the session, sir.
Thank you, ma'am.
Mr. Saru Vellarajan, sir, is the head of digital consulting at Ginkgos India. Sir has over 3 decades of experience working for leading organizations such as Cisco, Juniper, Ericsson, and Verizon. Sir is an MBA in Technology Management from University of Phoenix, USA. He has held several roles in product engineering, product marketing, and product management. He's also specialized in technologies such as cloud, wireless networks, IoT, edge computing, data science, artificial intelligence, and machine learning. He has presented in TEDx, TIE, TM Forum, Open Networking Foundation, DSCI, NESCOM, CII, PMI events, as well as conferences. He is also the author of the book An Introduction to 5G Wireless Networks, which is used by leading universities like the Anna University in their curriculum. Sir is currently pursuing his PhD in edge computing. We are honored to have you amongst us, sir, and I would now request you to kindly enlighten the House. Over to you, sir.
Thank you very much, ma'am, for the introduction. And I thank the BVI CAM organizers for providing this wonderful platform to enlighten the audience on 6G networks. I'm quite excited about the possibilities that 6G has in front of us. So in my session today, in the next 45 minutes, I'm going to quickly walk through the audience on the evolution of wireless networks and what is the current status of 5G adoption. And then I'll introduce the audience to 6G, the new capabilities enabled in 6G, and the different applications that are enabled by 6G. And towards the end, we'll look at who are the drivers who are influencing the 6G roadmap. Okay? So that's all we have for today. And like ma'am said, if you have any questions at any point in time, please share your queries in the chat window. We will look at them at the appropriate juncture. And in between, we do have audience polls. So I expect the participants to chime in and share their views when the audience poll question is asked. Okay. Good. So wireless networks. In fact, it has almost become ubiquitous, at least in the metro cities in countries like India, where there is hardly any place where you don't have wireless access. Like Hodas has shared with us, we do get different generations of wireless access in different places, but there is a decent coverage in metro localities for mobile wireless communication. It all started with 1G way back in 1983, where just voice calls were supported over wireless networks. And if you look at the application of the 1G, because the 1G phones used to be of the size of a brick, and those phones were used by people who were driving in their cars to make calls, emergency calls, or to ask for support when their car is stranded in the middle of the road. That was the primary application of 1G and when it supported voice calls. Then came the second generation of wireless technologies, and it was introduced around 1992 timeframe. And 2G supported SMS and email services. More specifically, the 2.5G, which is also called as the Edge network, started supporting email services on top of the mobile wireless networks. And the speed of those networks at that time was just 114 kbps. Compare that with several Mbps and even Gbps supported by 5G today, right? But the 114 kbps was adequate for accessing email over internet. And many of you would remember BlackBerry devices used to be quite popular during that time for providing email services. Then came 3G in the year 2003, and 3G enabled us to access internet from our browsers. Sites like yahoo.com and google.com became very popular because we were all able to access those from our mobile devices. And the speed that was supported towards the end of the third generation evolution of wireless networks was 42 Mbps. And then came 4G. Because in 3G, we had this problem where the browser, whenever you are trying to play a video online, the player would continuously buffer. It will wait for some time before it continues to play the rest of the video. And 4G came and solved that problem for us. 4G's primary objective was to enable video and online gaming services over mobile wireless networks. And though the initial version of 4G supported like 40 Mbps or so, by the time 4G matured and it reached its peak capacity, we were able to get nearly 400 Mbps speed on 4G connection. In fact, even today in countries like USA, we get anywhere from 200 to 300 Mbps speed on 4G phones. And obviously in countries like India, due to the population density, we get hardly like a 12 to 20 Mbps speed on our 4G networks. Starting 4G, we started also to pay attention on the latency. So latency is the time it takes for you to access services online. And 4G supported 50 milliseconds latency. And if you look at the reason for having improved latency is we are all able to make real-time video or voice calls over internet starting 4G. For example, the WhatsApp video calls that we all make over 4G, and some of you might have noticed in your own phones, you would see VoLTE, voice over LTE, which means the call is going over the mobile internet. So such real-time conversations and video communications are possible when the latency is very low. So if it is very high, then it's not possible for you to have real-time conversation and communication over the internet. Then 5G was launched way back in 2018. Verizon in US and South Korea Telecom in South Korea, they were all the pioneers in launching 5G way back in 2018. I still remember around the December 2018 timeframe, 5G got launched. And at that time, 5G standards were even not finalized, but these telecom service providers launched 5G because there is a race to be the first service provider to launch these services, right? So 5G started supporting 1 Gbps speed, and 5G supports less than 10 milliseconds latency. And that's what makes 5G apt for industrial adoption. Now, many of you may be thinking, oh, it's been a while since 5G is around, but the penetration is very low, right? But the real focus of 5G is not mobile devices. The real focus of 5G is industrial deployment and deployments like private wireless networks, right? So that's what 5G is focused on. And we see some great traction in deployment of 5G in industrial automation. So Industry 4.0 is primarily driving the industrial automation, and that's where 5G finds its place. And we also see adoption in fixed wireless networks. Some of you might have seen this product or service called AirFiber from Jio. So where today our broadband services are delivered over fiber connectivity, which means you have to run a cable to the home and then put a 5G, put a broadband modem connected to the fiber cable. But imagine having a modem in your home and it is not connected to the backend at all. It is communicating with the 5G towers and delivers high-speed internet access via Wi-Fi inside your home. So that is what is called fixed wireless networks. And a good example is AirFiber service rolled out by Jio. And in most countries, we have popular adoption of 5G for fixed wireless networks. Now let's take a quick look at what is the status of 5G adoption. So it was introduced way back in 2018, and it has reached a stage where we have roughly 2 billion mobile wireless connections on top of 5G. And you can notice that the 4G subscriber additions have started tapering down in the last couple of years, which shows that all new subscriptions are all happening on 5G. In fact, even in India, you would have observed that Airtel and Jio, they're all moving all of their subscribers to 5G plans, and they are slowly not rolling out incentives for users to stay in 4G, right? So there is nearly 320 wireless service providers who have deployed 5G all over the globe. And so that's a great adoption, right? So pretty much 5G is seen widely adopted across the globe. But at the same time, only 60 operators have adopted the 5G standalone implementation. Now, for those of you who are familiar, the beauty of 5G when compared to 4G and 3G is 5G can interwork with 4G networks. What does that mean? You can have a 5G antenna or a 5G radio access network communicating with the 4G evolved packet core that is running in the data center. So you can have front-end 5G antennas, and in the back-end, the core network services that take care of your authentication, policy management, billing, and subscriber quality of service experience. All of that would still run 4G. But then you will have the antennas providing 5G signals to the mobile devices, right? So that's how bulk of the service providers, nearly 3/4, right? I should say 3/4 of the service providers are still using 4G, but evolved packet core. That is called as non-standalone implementation. So non-standalone implementation means you have 5G RAN communicating to 4G core. So if it is 5G RAN communicating to 5G core, that's called a standalone implementation. Only 60 operators globally have started launching 5G standalone implementation. So that's because they have spent so much money in building the 4G core infrastructure, and they don't want to throw it away and bring in all new gear with 5G support. So they want to slowly phase out the 4G core infrastructure. That's the reason 5G started supporting interoperability with the legacy 4G core. And slowly operators are now shifting to the 5G core, which is the 5G standalone implementation. The two popular use cases of 5G are fixed wireless access, which is, for example, providing broadband access to home via 5G network. That is a popular service. And the second most popular service is private wireless network, where you can have a private 5G implementation within your factory or within your enterprise or within the facilities like airports. right? So that's those are some popular 5G use cases today. And private wireless network is still in its early stages of evolution, but there's already lots and lots of manufacturing companies doing pilots and trials with private wireless networks over 5G. Now let's look into what is new in 6G. 6G supports up to 1 terabits per second speed. Compare it with 5G. 5G today we are at 1 Gbps, and by the time we get closer to 6G, we would reach 10 Gbps speed on 5G, because 5G evolves to become 6G, right? So today 5G speeds are around 1 Gbps, and we expect 6G to hit 1 terabits per second speed. And look at the latency of 6G services, just 1 microseconds latency, whereas 5G is less than 10 milliseconds latency. So there is tremendous jump in terms of latency as well as speed, which makes it very appropriate for supporting applications like immersive extended reality. Now, many of you might have heard about augmented reality and virtual reality, where you wear those fancy VR headsets through which you can get transported to a virtual environment. And immersive XR is, for example, you can have holographic video calls. Imagine somebody standing in front of you and having a conversation with you as if they are just there in the room. That is a type of communication that you can have with 6G. And metaverse, many of you might have heard about metaverse type of services, which requires lots of bandwidth and ultra low latency. Immersive XR use cases would enable metaverse kind of communication. Then comes V2X, vehicle to everything communication. Now, many of you would know there are autonomous cars going around in the globe, especially, for example, in Palo Alto, a city where Google has its head office. There are autonomous cars that are going in Palo Alto roads, in San Francisco, in places like that, where there is no humans operating these cars, right? And in the future, these cars will have to communicate with other devices that are in the environment. So also called as V2X, vehicle to everything communication. So that is going to be powered by 6G. And then digital twins. This is a popular industrial use case where you can recreate the physical environment in a virtual world. For example, it's like more or less like a simulated environment, but the difference between simulation and digital twin is you are gathering parameters from the real world environment and passing it as an input to the digital twin, which is running in the simulated environment. You are running various models, various scenarios in digital twin, getting feedback from that, and then passing that back as input to the physical environment. For example, you can look at the operations of machineries in a physical world, and you can monitor things like thermal characteristics, noise, wear and tear of the equipment, and pass that as an input to the digital twin. The digital twin will come out with an output saying this machinery, considering the current utilization, needs maintenance in 10 days, right? So that is the kind of prediction that you can do with digital twins using 6G in industrial automation. 6G is expected to be launched by 2030. So it's still another 5 years, right? So 6G is in its early stages of research. There is a lot of players who are looking at what should be part of the 6G requirements. So 3GPP expects to standardize 6G in 2030 as part of release 21 specification. Today we are at release 18. Okay, so release 18 was standardized way back in 2023. Release 19 would get standardized in 2025. So we expect 6G to be launched in release 21. 6G's vision is to connect the physical, machine, and human world. What do I mean by that? Now, there is a lot of robots that are being used in factories and warehouses and in construction places, right? So these robots now can with technology like 6G can communicate among themselves. Machine to machine type communication can be enabled with 6G. Not only that, human to machine communication can also be enabled by 6G. For example, a human can give commands to a robot. For example, go and pick that inventory and bring it to the conveyor belt, right? So you can issue voice instructions to those robots, and the robots will follow your commands or instructions. Not just that, humans can give input in term using gestures as well. Remember the things that we used to see in Matrix movies, and that is possible now with 6G powered wireless networks. So the vision is to connect the physical environment with machines as well as the humans. And there is also a lot of possibilities using 6G in healthcare. Some of you might have already heard about things like robotic surgeries, where the doctors are able to do operations from remote locations. Such remote operations or remote surgeries require network reliability and high speed and low latency communication. So 6G is well positioned to meet such applications and use cases. So human to machine communications, machine to machine communications, as well as collecting feedback from the environment almost in real time. So that's the 6G vision. Let me ask you, so I've been talking for a while, so I want to hear from you. What is the role of spectrum and frequency in achieving higher bandwidth and higher coverage in mobile wireless networks? What is the relationship between, for example, frequency and coverage, or frequency and bandwidth? Any thoughts on what is the relationship between the spectrum and frequency and in terms of coverage?
Audience may write in the chat window.
Yeah, please type your responses in the chat window. Thank you, ma'am. Let's see who's going to respond first. Okay, Dr. Mishra. More frequency, more bandwidth. Superb. So the higher the frequency, the higher the bandwidth. Fantastic, sir. Thank you. Anybody else? Okay. So as we all would know, lower frequency, okay, higher the frequency, limited coverage. Okay, so I see a lot of responses now. Higher the frequency, limited coverage. Yes, that is true. Higher the frequency, more bandwidth, but limited coverage. Karthik, fantastic. Thank you. Sumit says more bandwidth can serve to achieve more throughput. Yes, bandwidth and throughput are directly related. Spectrum is very important for higher bandwidth. Yes, I agree. Dr. Sanjay says frequency proportional to bandwidth. Yes, great. Directly proportional to bandwidth. Lower frequency can travel long distance. Ganesh, awesome. Yes, so lower, for example, 2G and 3G networks, they were all supporting less than 1 gigahertz spectrum. And 2G and 3G had better coverage when compared to, for example, 5G, right, or 4G. To achieve the coverage, you need to use those lower spectrum ranges even in 4G and 5G. Otherwise, you would not have better coverage. Okay, good connectivity and broad spectrum. Okay, superb. Good. So kudos. Thanks for participating. And let's look at the spectrum range supported by new spectrum range that is getting supported in the case of 6G. So 2G, like all of us would already know, supported low band spectrums, right? For example, 700 megahertz, 800 megahertz, and so on. So typically spectrums that are in the less than 1 gigahertz range. 3G started supporting the mid band, which is 1 to 6 gigahertz spectrum range. And then from 4G onwards, we started supporting the upper mid band. So remember, 4G has to support higher bandwidth and higher throughput. Like many of you said, higher frequency means higher bandwidth. So 4G started supporting the upper mid band. And from 5G, we started supporting high band spectrum range. Now, some of you might have heard this term called millimeter wave. So the millimeter wave is the spectrum range between 30 gigahertz to 300 gigahertz. So 5G started tapping into the millimeter wave. So it supports high band spectrum from 24 gigahertz to 100 gigahertz. Starting 6G, we are getting into the sub-terahertz world. Okay, so sub-terahertz world is so ultra high bandwidth, 100 gigahertz, 200 gigahertz, 300 gigahertz, and up to 10 terahertz. So sub-terahertz and terahertz frequency ranges are going to be supported by 6G. So it would enable devices that are within reach to communicate among themselves, right? For example, imagine an industrial scenario where you have equipment that are trying to communicate among themselves over short ranges, short distance. So that's where the ultra high band would be of very apt need, right? So that's where it gets used. So as this graph says, the lower the spectrum, the higher the coverage, and the higher the spectrum, the lower the coverage, but higher the bandwidth. Okay. Let's listen to some experts on what are some potential research areas in 6G, right? So this video has representatives from different industries and different roles. Let's hear from them.
There are definitely research areas in 6G which are currently not addressed by the 5G or 5G and beyond standard.
The colleagues are working on higher frequency coverage, D-band, sub-terahertz communication, and not only communication, but also channel sounding, sensing applications. That's where we are going, reaching gradually and step by step into higher frequencies, and higher frequencies offer the opportunity to cover wider bandwidths, an area where we are also active already.
We want to bring, laboratory discoveries, new physics towards technology that can benefit society.
I would first say that you call it the universal internet, for this IoT type of devices. I think it's the next generation of mobile broadband. And then I would call it these reliable real-time communication, where then all those XR, VR, AR type of devices will be in.
How can we make sure that we're getting low latency communication? The best way to have low latency is be able to transmit and receive whenever you want. So technologies like full duplex that enable that interference cancellation with intelligent beamforming, with intelligent processing and scheduling, those go hand in hand to make sure that the air interface can evolve into new sensing applications, into that RF understanding.
And also we have been looking at the technologies like RIS, which includes reconfigurable intelligent surface. That also allow us to manipulate the propagation of RF signals and so on.
Okay, so you listen to the experts on what are some potential research areas in 6G that these entities are looking at. So what's new in 6G? So I've handpicked a few items that stand out. So 6G is going to support intelligent network architecture. Now, all of you would have heard about artificial intelligence, machine learning, generative AI, and things like that. So even our mobile wireless networks are going to be more intelligent going forward. I'll walk you through how it's going to be intelligent going forward. Then we have support for heterogeneous clouds. Now, all of you would have already heard about edge computing, edge cloud, where the cloud is getting more distributed and cloud infrastructure is getting placed near to users. So 6G is going to embrace that development. 6G will also explore and embrace extreme MIMO, and extreme MIMO is going to help us achieve higher coverage, and it's also going to help us connect to more equipment. Imagine Internet of Things, where there will be several billions of devices connecting to the internet. Extreme MIMO will help us connect all the billion devices to the internet or using mobile wireless networks. Then holographic beamforming. This is a technique that is used to ensure that the user always gets consistent high coverage. Imagine drones going around in the community doing surveillance. These devices need continuous connectivity to the network to transmit the video feeds that are collected from the community, right? So such applications and use cases are enabled by holographic beamforming. Then comes subnetworks. With 6G going to be widely deployed in several industries, for example, for automating the manufacturing processes, for using in healthcare, in hospitals, to monitor patients' health, and in smart home automation and smart community automation, 6G is going to introduce us a new concept called subnetworks, where you can have smaller networks deployed and managed in these different places. Then comes integrated sensing and communication. We are all already familiar with a lot of tech devices being connected to human bodies, especially in the healthcare industry, for monitoring the health of human vitals, right? For example, smart device, smart watches, and we see glucose monitors that are getting digital. So there is a lot of devices that are coming up which are being used to improve the quality of life for humans. So integrated sensing and communication is a new capability that is enabled to connect all the devices that are out there. And not only that, so far we have seen 5G and 4G being used to just communicate, right? Now with 6G, the same wireless signals will also be used to do sensing. For example, geospatial discovering what the objects and the physical environment, which will be very useful in the case of, for example, autonomous cars, or if you are doing geospatial mapping, then you can do that with 6G. So these are some new capabilities introduced in 6G. And in the next 20 minutes or so, we'll spend some time to understand each of these capabilities in detail. So first, the intelligent network architecture that's supported by 6G. Now, many of you would already know that any wireless network has two distinct components. One is called as the RAN, radio access network. The other is called as the core network. So the core network normally runs in the service provider's data center, and radio access network is deployed in the public locations. For example, your tower is also part of the RAN, and RAN is also responsible for converting the electromagnetic signals that are analog in nature to digital, and converting digital signals back into electromagnetic signals, the analog signals, right? So that's the purpose of RAN. And in 5G, the RAN got virtualized, which means you can run some of the RAN capabilities in a cloud. And with 5G, we also started deploying edge cloud, where you can run gaming applications or augmented reality, virtual reality type of applications, or even industrial applications near the user. So this ensures that the latency of the communication is very low. So this is the typical architecture of any wireless network. Now, 6G and 5G, they both can interop with each other. In fact, one of the requirements from most telecom service providers is we have invested significantly on 5G. We don't want that investment to go away when 6G gets introduced in 2030. So the service providers want 6G to interwork with both the RAN as well as the core on the with 5G components. That's one of the key requirements for 6G. And mobile backhaul is typically the fiber network that connects the RAN with the core network. Now, these different components and entities are managed by the operation support system that are deployed in the service provider environment. Predominantly fault management, configuration management, and accounting, performance management, security management. All these capabilities are delivered from the operation support system. Now, what is so unique about 6G's architecture is it now supports AI and ML models in multiple points in the network. So you can run AI ML models in the RAN or in the edge cloud. You can run AI ML models in the core network, and you can even run AI ML models as part of the operation support system. For example, imagine a scenario where, for example, you are deploying 6G in a commercial district. Now, one of the characteristics of a commercial district is there is a lot of people who will hit the commercial district during the daytime, but in the evening time, there will be hardly any people, or in the night time, there will be hardly any people, right? For example, your IT complexes or IT parks. So you have a lot of people hitting the IT parks during the daytime, very few people or negligent number of people during the evening or night hours. Now, one of the challenges for service providers today is irrespective of whether there are 100,000 users or there's just 100 users, they still have to keep all the tower and the RAN components up and running, which means they are spending money on power, they are spending money on cooling, they are spending money on growing their real estate footprint, right? So what if you can intelligently predict how many users will use the network at a given point in time? Like, for example, before we go out on our car, we just look at Google Maps to find out which of those roads are marked in red, right? So similarly, in wireless networks, you can have identify time of the day where there is lots of footfalls in a given location, and accordingly, you can dynamically turn on and turn off radio modules or RAN modules that are running in the cloud. you can optimize the power consumption, you can optimize the cooling, and you can even improve the efficiency of the devices, right? So that's one of the AI ML based resource allocation in the radio access network, or resource management in the RAN network is one of the applications of the AI models in the 6G network. Now talking about core network has a lot of processing power when compared to the edge or the RAN. So in core, for example, 6G is targeted at industrial automation. You can find out the location of drones or autonomous vehicles in a factory, and you can assign resources proactively in the radio networks based on flight path prediction. So for example, flight path or trajectory prediction of these moving machines can be decided by running the historical flight paths or trajectory of these equipment in factory. Based on that, you can proactively allocate resources on be it the tower or be it in the RAN or even in the core network. So that is possible with AI/ML models running in the core. Not only that, you can even provide location-based services to the user. So you can look at the historical locations of users, and based on that, you can proactively, for example, suggest alternate route for users to go, or you can even have location-based advertisements delivered to the user by processing their historical mobility data. Then comes more intelligent management of the network from the operations support system. For example, you can monitor how much resources are consumed in the core, how much resources are consumed in the RAN, and you can plan for further capacity increase on these entities in the wireless network by running AI/ML models. Or you can do dynamic QoS allocation for users. For example, the users access different types of services. The quality of service requirement for a video service will be different from the QoS for an FTP service. So you can intelligently monitor this and allocate quality of service dynamically to ensure that the user experience is not impacted for these services. So you can run such AI/ML models in the as part of the OSS and dynamically provision capacity in each of the RAN or the tower or in the core network. So these applications are possible with AI/ML support in the 6G network. So 6G network is not going to be a static network like 4G and 5G. It's going to be more dynamic, and it's also going to be more intelligent. Then let's look at the heterogeneous cloud architecture. Now cloud is almost ubiquitous. You see AWS, Microsoft Azure, and Google deploying cloud left, right, and center. We have lots and lots of public cloud infrastructure already available. And service providers, not all service providers are deploying their workloads in public cloud today. I know AT&T is one of the pioneers in trying to switch their core network software into the public cloud. They are running it in Microsoft cloud infrastructure, but not all service providers run their wireless workloads on public cloud infrastructure. But with 6G, it's going to provide lots of options for the service providers. The service providers can run their core network services or RAN services on an edge cloud or as part of the telco cloud. The telco cloud is the core network cloud, or on a public cloud in centralized public cloud data centers. In addition, if you have private cloud infrastructure deployed in industries or airports or shipping ports, then you can even have some of the core network services and functions running on these private cloud environment also. Why should we do this? It gives a lot of flexibility for service providers, and it also helps to ensure there is security of the services that are delivered in, for example, private networks. It ensures that the latency of access for the services is very low. Remember, 1 microsecond latency. For supporting 1 microsecond latency, you need to run the services very close to the user. If you are running it in the public cloud, then it's going to be 200 milliseconds, right? So whereas when you are running in the private cloud environment, then you can have microsecond latency because the infrastructure and the application are running pretty close to the devices, right? So this architecture provides flexible deployment options for running RAN, core, and even application services for the service provider. And not only that, it provides cost efficiencies, right? When you are having lots of edge cloud, for example, you may incur higher cost. When you are moving workloads to the public cloud or centralized data centers, then you are reducing the cost. You can optimize the cost by dynamically moving workloads from edge cloud to the public cloud or from public cloud to the edge cloud. So that is another benefit of the heterogeneous cloud architecture. So before looking at what is extreme MIMO, let me ask you, what is the role of MIMO in wireless communication? What is MIMO? Okay, so Ganesh says multiple input, multiple output. It can increase the cell capacity. Sumit, fantastic. Okay, good. So in essence, multiple transmitting antennas and multiple receiving antennas, right? So Sumit rightly said, it can improve the overall cell capacity when you have multiple antennas transmitting and receiving signals. So in 4G, we had 2 to 8 antennas part of every MIMO antenna. So you will have 2 to 8. When they say antenna, it's like the radio modules that you see in the picture. That's a copy of the real world MIMO antenna, which has 4 radio modules. You can have minimum of 2 and maximum of 8 radio modules transmitting and receiving signals. Then with 5G, we introduced massive MIMO. So massive MIMO can pack large number of radio modules within an antenna. So for example, in the picture, you see 8 radio modules in each row, and then there are about 12 rows. So you can have close to 108 radio modules. So what is the benefit of packing more radio modules, right? Like Sumit says, you can have a higher cell density, which means you can allow multiple user equipment or devices to connect to the network. And with massive MIMO, you can have large number of IoT devices in a factory connecting to the network. Now, massive MIMO also has a capability where you can send multiple signals towards the users so that the receiving user always gets coverage, right? So massive MIMO helps you to connect, let a large number of devices connect to the network, and it also ensures that the coverage is always high for these devices. Now 6G is taking it to the next level by packing nearly 1,000 plus radio modules in an antenna. So 6G supports simultaneous connections from several thousands of devices. Remember again, this advancement is not for just mobile subscribers, right? So today we are all already good with 4G or even 5G, but this advancement helps us to connect drones, several thousands of drones that are moving around in a location, right? For example, today you may be hearing that drones are getting used for even surveillance across the border in several countries. So, and you can have large number of small IoT devices that are being used, for example, sensors and actuators that are used in manufacturing facilities that require connection to wireless connections to the network. So such deployments would get benefited with extreme MIMO. So you are packing several radio modules into an antenna. So to ensure that all these devices are getting high coverage, to ensure that several thousands of devices can simultaneously connect to the network. So one of the benefits of using extreme MIMO antennas is, for example, you can deploy 6G with minimal infrastructure in a large urban locality. The characteristic of a large urban locality is there will be a lot of obstructions, right? So in order to provide support for line of sight, because only when the tower has a line of sight with the user equipment will have coverage. Now with 6G, they are introducing a new concept called reconfigurable intelligent surfaces. So the reconfigurable intelligent surfaces will act like a mirror for the signals. So it receives signals from the 6G tower, and it reflects those signals towards the user, and these are all programmatically controlled. So imagine reconfigurable intelligent services like window panes the windows or glass walls with silicon embedded in them, and they can be programmatically tuned in terms of amplitude and phase of each of those modules. So that's what reconfigurable intelligent surfaces provide us. It ensures high coverage for users, and it allows us to have lots of antennas embedded or radio modules embedded in a glass window or a glass door, right? So they can be electronically controlled to redirect signals to provide a better coverage for users, and thereby also user will be able to have low latency communication with the network. So reconfigurable intelligent surfaces is another evolving research area in 6G. So let's watch a short video on beamforming, and then I'll talk about what is holographic beamforming.
Hi, it's Mike Wood here from Telstra, and I'm with Meg and Vinaya, two of our exciting graduates from 2023. We're on the Gold Coast, which is where we've got one of the Telstra 5G supercells. That means it's got 5G low band, 5G mid band, including standalone, and the exciting new millimetre wave technology. What we're going to demonstrate today is millimetre wave beamforming. What that means is that one of the efficiencies of beamforming is that it can send a narrow beam to individual devices. That's how you get great efficiency and great throughput on 5G. So what we're going to do, Meg and Vinya are going to walk in a straight line across these three measurement probes, and on the spectrum analyzer, we're going to show you the signal come up on one, then on the middle one, and then on the third one. And that's the individual, we're tracking the individual beam. So Vinaya is going to activate a Google Pixel 7 millimetre wave phone, and we're going to see she's going to walk across in a straight line across three probes. They're connected to these individual spectrum analyzers. So you'll see the signal come up on the left-hand side, then in the middle, and then on the right-hand side. So let's give this a go if you want to come up above. Okay, Vinaya, activate your Google Pixel and let's see if we get a connection. We've got millimetre wave on the left-hand side. As Vinaya moves to the middle probe, you can see it on the middle. And as Vinaya moves to the right-hand side, you can see it come up on the right-hand side probe. So that's demonstrating the power of millimetre wave beamforming, being able to send a beam to an individual device, which gives you that great efficiency on 5G.
Okay. So that's a demonstration of beamforming in 5G. Now what you are going to get in 6G is what is called as holographic beamforming. Now look at this graphic where you are receiving signals from the tower, the transmitter on the left-hand side, via a window pane, and it hits a wall where you have a RIS, reconfigurable intelligent surface. So it hits the wall, and the RIS would be able to shape the beam towards the receiver. So it enhances the coverage of signals for the user, especially in locations where the signals that are coming from the tower are hard to penetrate, right? So that is what is called as holographic beamforming. So you can have multiple vertical as well as horizontal beams that are oriented towards the user equipment, which is the receiver. And that is like a 3D hologram. That's why it got its name, holographic beamforming. So holographic beamforming is possible with reconfigurable intelligent surfaces, and which will enable highest coverage possible for any device. Mostly imagine moving devices or devices that are operating in, for example, basement area or in mines where the signals from the macro cell are hard to penetrate. Those are the locations where the holographic beamforming with RIS will be more useful. And 6G also brings in this concept of subnetworks, where then the existing physical infrastructure can be partitioned into several network slices, and you can allocate each network slice to different applications, right? For example, a manufacturing application can be placed in one slice, and a robotic application can be placed in another slice, and a V2X, vehicle to everything communication can happen in a different slice. So in 5G, they introduced this concept of network slicing, and in 6G, they are enhancing it further by adding machine learning capabilities where these slices are intelligently created and allocated dynamically to different applications on the network. So these are, you can visualize them as smaller virtual networks in the which gets created from the larger 6G network. Okay? it has a lot of application in terms of improving performance, efficiency, and security in a large 6G network deployment. So in the interest of time, I'll jump to the integrated sensing and communication topic, which is now you have already seen the use of reconfigurable intelligent surfaces. These are like window panes or mirrors that reflect 6G signals so that the 6G signals can hit a large number of users in urban locality. And with 6G, you are also going to have support for non-terrestrial network. Now, all of you are familiar with terrestrial network, which is the towers that are deployed on the terrain, right? The terrestrial environment. Now with 6G, you will also have the radio modules or the RAN environment running in high altitude platform station, right? Google balloons. Some of you might have heard about Google Loon project, right? Where you can send a balloon to a disaster struck area, providing radio coverage to users in that locality. You can have a high altitude platform station like that, or you can have low Earth orbit satellites, or you can have RAN coverage provided by a drone that is running on the top, right? So these can be used to provide higher coverage of signals, especially Hodo sir talked about providing connectivity to remote rural location, right? So those are all possible now with high altitude platform stations or unmanned vehicles acting as towers. Now the beauty of 6G is it not only uses these devices to communicate, but it uses these signals to sense the environment. Imagine infrared using thermal radiations to find out the objects in an environment. So you can do similar things with 6G signals. Because as you send signals and they hit objects, they'll get reflected. The strength of the signal, the orientation of the signal, all of that, the phase of the signal will also change drastically. So by running machine learning algorithms, you will be able to possibly detect whether it's like a large building or whether it's a moving bus or a train, or whether it's a small object like a tree that is oscillating. So you'll be able to sense the environment. So sensing the environment is very useful when, for example, you can have a defense type of application, or even in industrial environment, you can find the quality of the finished product by using sensing capabilities. You can also use sensing to monitor the vital health or even motion of users in a locality. So there is so much possibility with integrated sensing and communication. So that's the same antenna, same radio signals, but used for a different purpose to sense the environment, to scan objects in a locality by running machine learning algorithms, right? So 6G signals are used for reconstructing images in a landscape, or map an environment where there is a lot of physical objects, right? So it can be used to detect the location, shape, and properties of different objects. So to summarize, these are the different applications and use cases of 6G. By supporting the intelligent network architecture, you can have more AI-driven dynamic resource allocation. You can also have personalized user experiences by allocating dynamic quality of service for users in an environment. By supporting heterogeneous cloud, you can have multiple cloud, be it public cloud or private cloud or edge cloud or telco cloud. You can orchestrate services across different clouds. Not only that, you can support low latency services, for example, augmented reality, virtual reality, or even hologram type of services by hosting these applications near the end users. With the Extreme MIMO, you can have support for high-speed data in dense user locations. Imagine a stadium filled with users. With Extreme MIMO, you can provide connections, reliable connections to all those people in a stadium. And not only that, you can have coverage for applications like remote robotic surgeries. With holographic beamforming, you can support use cases like holographic telepresence. Today, we are all doing Zoom calls, WebEx calls. Imagine with 6G, we can have telepresence where we'll all be sitting in a room or in a conference hall and doing this session, right? So that's possible with 6G. You can also use it for geospatial mapping of by scanning and looking at things in an environment. Then with sub networks, you can do automation within smart home or smart community. You can also enable vehicle to vehicle or vehicle to other object communication with different network slices created using machine learning algorithm in an automated fashion. Then with integrated sensing and communication capabilities, you can have a body area network. Imagine a patient getting monitored using different equipment. These equipment can communicate among themselves. So that's body area network. You can also use integrated and sensing for gesture-based communication in an industrial environment, human-machine type of communication, right? Gesture-based. So that can be enabled with integrated sensing and communication capability. So lot of players in this 6G race today. There is on one side the vendors like Ericsson, Qualcomm, Nokia, Samsung. They're all leading the game in 6G research. On the other side, you have standard bodies like 3GPP, Next Generation Mobile Networks, International Telecommunication Union. 6G Flagship is an initiative from Finland, and HexaX is an initiative from Europe. Bharat 6G Alliance is an initiative from India. So these bodies are also contributing to the 6G standards, and telecommunication service providers from Japan, US, China, and South Korea, they're all playing a leading role in 6G standards at this point. So that brings us to the end of a quick intro to 6G. Now I'm open to take questions.
Thank you, sir. Thank you for the wonderful session. I would say it was not a brief intro. It was actually a very detailed introduction. So we have many questions from the participants. I'll take up a few with your permission.
Sure, ma'am.
First question we have, do we actually have the suitable frequency band for 6G networks in India?
Okay. So at this point, and countries like India, for example, we the spectrum and allocating spectrum for different applications, it's all governed by the government. And so far, they have not licensed any of the 6G spectrum to any applications yet. Okay, so there is no official allocation of the 6G spectrum for any commercial use or public trials and public use yet. But yeah, in terms of availability, yes, they are available.
So how soon or later can we expect 6G to replace Wi-Fi in an office or organizational IT environment?
So in fact, yesterday I saw this article where Verizon, that's where I used to work for, the CEO of Verizon said, you don't even have to turn Wi-Fi in a stadium environment. You can all use our 5G services and get uninterrupted high-speed connectivity. And the goal, at least for the telecom service providers, is to replace Wi-Fi, right? But considering the Wi-Fi penetration, I don't think even 6G would replace Wi-Fi. It's going to happen, probably they both will coexist in the shorter to medium term.
Absolutely, very rightly said, sir. What would be the practical constraints in the actual implementation of 6G networks? Like what kind of infrastructure preparation would the country have to actually make?
Okay, great question. In fact, this is one of the challenges even for 5G, because with 5G, we have to roll out what is called a small cell. These are like mini mobile towers that have to be deployed in almost like all light poles or on the corner of your street to support high bandwidth 5G connection, right? For example, 1 Gbps speed, if you want to achieve over 5G network, then you need to have these small cells deployed in several locations. For example, within an enterprise, you need to have a small cell, or under the parking garage, you need to have a small cell to provide the 5G high 1 Gbps speed, right? Now talk about 6G. 6G is promising to support even up to 1 terabits per second speed. So to get such highest speed, you need to have towers, mobile mini small cells deployed in almost every home, right? And that's when you will get such high speeds. And there's going to be more antennas deployed around the street and homes to enable 6G. What I feel is it's not going to be massively deployed like that. But in private wireless networks, right? For example, within a factory or within an industry, they'll have a lot of antennas to support 6G like speeds. Or in select deployments like airports or shopping malls, you will have where you will have 6G like speed. But then you're not going to get 6G like 1 terabit speed from your house, right? You are better off with Wi-Fi for such applications.
Absolutely, sir. Very rightly said. What would be the radiation effects of 6G on living beings?
Okay, so I'll share with you the current state of the art. So the current state of the art is several trials and experiments have been done with the latest 5G, and specifically one of the concerns is what impact it has on humans and animals. There is no research or study that has conclusively proved that 5G radiation will have a significant damage to humans. What is proved at this point is if you put a small animal like a rat in a radiation chamber and you keep that in the radiation chamber for several months in a row, then the rat shows signs of cancer. Okay. So obviously 5G we are not like hugging the 5G towers and sleeping every day. So we are still far away from that kind of a scenario. So it's not proved yet that 5G and even for that matter, the upcoming 6G is going to have a great impact on humans, but we have to wait and watch, right? So we don't know how 6G is going to be deployed and rolled out 5 years down the line. But for now, there is no research that has conclusively proved the impact of the mobile wireless network radiation on humans or animals.
So one last question we have. What are the possible vulnerabilities and exploitation available for attackers in 6G? Like 6G, is it going to be more secure or is it going to be more vulnerable?
Okay. Yes and no. It's going to be because the attack surface is going to grow. You are going to have more components that are deployed in 6G network. For example, the reconfigurable intelligent surfaces. These are new components that are coming into the mobile wireless network. So the attack surface is getting widened. So the possibility for attack is going to be higher in 6G network. But at the same time, now, one of the things that 6G researchers are looking at is quantum safe cryptography and using blockchain to share and exchange data with the different components. So blockchain and quantum safe cryptography is going to be part of 6G, which will ensure that the data that is getting shared between these different devices and from the devices to the core network and to the internet is all going to be secure. Okay? So while the attack vector or surface is going to be huge, there's also going to be more technologies that we can embrace to keep our data secure.
Thank you, sir. Thank you for the informative session and the wonderful answers. So with this, we come to an end to this wonderful session today, but we'll not be ending this session now. I would now invite Professor M.N. Hooda, sir, to kindly present, sir, with a memento and a certificate as a token of remembrance for this wonderful session today. Hooda, sir? Sir is traveling, so
okay.
I'm not sure if he. Hooda, sir, am I audible?
No worries, ma'am. I'll virtually receive it.
Yeah.
Thank you.
Yeah, you are audible to me.
Yes, sir. Sir, please present, sir, with a memento and a certificate for this wonderful session.
Thank you so much, Mr. Saro. 6G is yet to see the light of the day, but the session will remind us when it will be prevailing in the country that we had this session at the time when people were just thinking about it. And certificate and memento both are not for the purpose of certification, rather for the purpose of remembrance that you have been part of this lovely session, using which we have sensitized audience, we have sensitized our participants that how and in which way 6G is going to embrace all of us.
So we even
and thanks, Ajay.
Thank you. Thank you, sir.
you. Thank you very much for the opportunity.
Thank you. Thank you.
Thank you, sir. The pleasure has been ours. It has been a wonderful session today, and we hope to meet you soon in the future with another wonderful session.
Sure, ma'am. Thank you. Looking forward to it.
Thank you, sir.
Thanks, Ajay. Thank you.
Okay.